Hey, fellow developers. Hi, welcome to day 10 of Advent of Code 2024. And if you haven't checked out my previous 9 days of spoiler free discussions, you can check them out right here. And today we are speaking from a Decagon face cam because day 10. So without any further await, let's get started. So the day 10 problem today is called Hoof It. So we have a whiteboard. Let's read the problem. So you all arrive at a lava production facility on a floating island in the sky. As the others begin to search the massive industrial complex, you feel a small nose boop your leg and look down to discover a reindeer wearing a hard hat. And if I'm right, this lava production facility is from 2023. Oh, yes, it is. I wrote a blog about it. Yeah, I remember generating this reindeer with respect to the lava island, and then there was a lava production facility. Anyways, moving on. So the reindeer is holding a book titled Lava Island Hiking Guide. However, when you open the book, you discover that most of it seems to have been scorched by lava. As you are about to ask how you can help, the reindeer brings you to a blank topographic map of the surrounding area. So, topographic maps are, I am sure you would have seen those maps that basically goes like explaining a terrain, how a terrain is. I think we are given a link here as well. This one. So that helps you understand what is the elevation of a terrain and how it changes based on where you go. So let's read more. So perhaps you can fill the missing hiking trail. The topographic map indicates the height at each position using a scale from 0 to 9. So the scale goes like 0 to 9, where 9 is the highest peak and 0 is the lowest peak. And for example, we are given a topographic map here. So let's copy that, make it a little bigger so that we can read more. Yeah. So we are given an example here, and based on the unscorched scraps of book, you determine that a good hiking trail is as long as possible. So we are given some ground rules for calculating a path. So the path should be as long as possible. And the second one is that it should have an even and gradual slope. So it should have like an even gradual slope. And what that means is that for all practical purpose, this means that hiking trail is any path that starts at height 0. So it will start here and ends at height 9. So it has to end here. It's basically like a maze finding question, but with a hiking trail. So, and it always increases by height of exactly 1 at each step. So I think that means that the delta between each step is always 1. So that explains the even gradual slope, because you don't want to jump directly from like 1 to 8 here, right? And the hiking trail never includes any diagonal step. So I think the only 4 directions you can go is left, right, up, and down. You look up from the map and notice that the reindeer has helpfully begun to construct a small pile of pencils, markers, rulers, compass, stickers, and other equipment you might need to update the map with the hiking trails. That's good. So a trailhead is any position that starts at one or more hiking trails here. These positions will always have a height of 0. So for the start pointer, I think we are calling it a trail head. It's like a head of a linked list node, maybe. Maybe that's a hint. And assembling more of the fragments of pages, you establish that trailhead score is the number of 9 position reachable from the trailhead via hiking trail. So we have to calculate a score, which is basically assembling more. You establish it is the number of 9 height positions reachable from that trailhead via hiking trail. So idea is we have to calculate like how many 9 height positions can we reach if we start from 0. In the above example, a single trailhead in the top left corner has a score of 1 because it can reach a single 9. So it seems like if you follow my cursor on this output in the given example, we first of all we only have one peak where we can reach, and there are multiple ways of reaching here. So remember, we can only have a even gradual slope of 1. So one path I can see, if you follow my line, is here, which follows 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Another path is 0, 1, 2, and instead of going right, we go down, and then we go right, and then you follow the same path. There is another path where you go down from 1, 2, 3, 4, and then follow the same path. There is one where you go like this, but you again follow the same path back to 9. And similarly, 1, 2, 3, 4, no matter how many steps you do, from 5, instead of going down, you can go to 6, 7, 8, 9, and 7, 8, 9, and then 6, 7, 8, 9. There is a siren in the background, so we should wait for that to pass. Okay, we should be good now. So, but overall, the score here, since there is only one 9 position that we can reach, the score here will be 1. We are given another example right here. So here also the trailhead is 0, where we will start from. And if I start traversing, I can see I will go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is one peak. And then similarly, I'll go 0, 1, 2, 3. I'll turn here. I'll go here and I will find another one. So the answer here becomes 2. That's what it mentions here. The position marked as dot, the periods are impossible tiles. To simplify these examples, they do not appear in your actual topographic map. Okay, that's good. And this is just for simplification. This trailhead has a score of 4 because 9 is reachable via hiking trail except one immediately to the left of trailhead. So let's do a dry run on this as well. It's important to do as many dry runs as you can to build your understanding of a problem before you jump on to write code for them. That helps you understand all of the edge cases, because a lot of times the devil is in the details. And yeah, so let's read this example. So here also it's in a similar way. Our starting position would somewhere be at a trailhead. So we see a trailhead here, 0. And now starting with this, we can see like we have one peak that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the one. Another one is 4, 5, 6, 7, 8, 9. And then there are multiple ways of reaching here, but I'm not going to look at them. And then the other one is 4, 5, 6, 7, 8, 9. And from here, there is another one that is here. So we have a total score of 4, but you may ask, what about this one? So this one is not going to work because the delta between 0 to 9 is of 9. And remember, on the top, we discussed that one of the ground rule is that every gradual step should have a delta of 1. So you can basically go up in the elevation only one elevation step at a time. So this is why this won't work. So the answer is 4. And then we have another example. So let's look at this.
And I'll paste it here, make it wide, increase the opacity, increase the size.
Yeah, so now looking at this example, we have another example where our topographic map contains 2 trailheads. So if we look at this, I have pasted it here. We have a trailhead here and we have a trailhead here. Let's try the first one. So starting from the first one, if we go to 0 to 1, 2, 3, 4, 5, 6, 7, and if we go down 8, 9, we get to one peak. But if we see here from 7 to 6, we cannot go here, because if we read the question again, and this is an interesting edge case where even I had to go back and read, this is an important one, that it always increases by a height of exactly 1 at each step, and there is no diagonal steps. And then it seems like you cannot also go down a step. So in this one, from this trailhead, you can only reach one of the peaks. But if I see this another trailhead, if we start from here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can reach 1. And from here, since we are still going up like 6 to 7, we can also go here and go to 7, 8, 9. And this one, it seems from here we can reach 2 peaks. And this is another larger example, and this has 9 trailheads. And considering the trailheads in reading order, they all have different scores. So similarly, we have score 1 and 2. We have scores of 5, 6, 5, 3, 1, 3, 5, 3, and 5. And what the answer is that they are adding these scores together, and the sum of the scores of all trailhead is 36. And if we want, we can do a dry run, but I think I leave that exercise to you as a viewer. What you should do here is you should take this example And don't skip this step. This will help you understand the question a lot more better. And once you have this, create multiple copies. You can do it in your notebook, pick a pen, and then like maybe find a trailhead. So let's say if I start from here, I'll show you for one. So if you start from here, you can see that we can go in 0, 1, 2, 3, 4. And from 4, we can go to 5, 6, 7, 8, 9. And then another one from this 7, we can keep going up 7, 8, 9. So we have 2. Let's see if we have more. So from this 3, we could have gone to this 4, but this would go back to the same trail. From this 1, we cannot go anywhere. From this 2, we cannot go anywhere but here. From this 4, we can go to 5, we can go to 6, we can go to 7, we can go to 8, we can go to 9. So we have found another one. So from this 8, we can also go down. So we have found another one. And let's see. So from this 5, 6, 7, 8, 9, 8, 9, that's there. 6, 7, 8, 9. There is another one, which is here. And I think this brings us to the end of the trail. So we have 1, 2, 3, 4, 5. So total of 5 trailheads, and that is what it's given in the answer. So I think I will urge you to try for these other trailheads. So we have one trailhead here, we have one trailhead here, one trailhead here, basically all the zeros that we can see, and start from them and try to see like how many trailheads you can find, how many peaks you can find, and then add them together. So there is another siren. Let's wait for that to pass. I'm going to cut this. Okay, it seems it has passed. So yeah, so once you calculate the number of peaks, where a peak is basically 9, so like number of peaks that are accessible, all you need to do you need to do a sum of all these peaks. And they have to be unique peaks, because remember, even in this example, so here if you see from 0 to 9, there are multiple pathways to do that, but we still will only count that peak only once. And with that, I think we will calculate the sum and then we will feed it to the puzzle. And we are given a puzzle input, which is fairly large and contains a lot of trailing heads that are our starting positions. And we will have to calculate the number of peaks and do a sum of that. And with that, I think it's a good time to pause the video here and think about the discussion that we have. And we did some dry run in how you will solve this puzzle. And once you are back, I will share a couple of initial hints that I can think of to write some code and try to solve this problem. Hey, so if you're still here looking for a hint, what I can think of is, let me write it down. I think you first have to think about how you will represent this grid in memory. And I think by just using a grid, it becomes very similar since we are doing a lot of traversals, it makes sense to use like a 2D list or an array based on what language you are using. And the second most important aspect is that how will you efficiently find all the possible paths from your starting position? So all paths from 0. And this is a classic grid traversal problem where starting from a path, you can go in 4 directions. So left, right, up, and down. The other one is we can only increase by 1 at a time. So this helps reduce the scope of the problem by a lot. And this problem is interesting in tradition sense that even if you use a classic graph traversal algorithm, maybe breadth first search or a depth first search, there is a simple twist that we don't need to track visited nodes here, because in traditional sense, we can only visit higher numbers anyway. So anytime you keep going high, anytime you feel like there is a path that you cannot go to, for an example, from this 0, if you start with 1, it's not like you can go to this 8 anyway. So, and if you cannot go to the 8 anyway, it's not like you will traverse for more paths in future. So it's quickly elimination here. And by doing this, your code becomes much more simple and cleaner, and you are able to think more properly about that. And when implementing these solution, you need to understand how do you effectively store and process the grid, how do you handle the path validation. Based on what type of traversal you use, a BFS or DFS, you will have to write some code by keeping these constraints in mind. And then you have to avoid counting the same peak, that the 9 point again and again, because as we discussed, there are multiple ways of reaching the same path. So maybe you have to think about using a set there. And I think that should be it. By having all of this information at your disposal, I think now is a good time for you to open up that IDE and write some code. And I'm also going to do that. And remember, always the best practice is to first start with all of these test cases that are given in the question, because these have tons of edge cases baked into it. And once your code is able to find the correct answer for all of these test cases, then it's a good idea to move on to the puzzle input. That will ensure that your code is robust and handles all the edge cases, and there is a very high chance that you will get the correct answer in your first attempt. So all the best, and I will see you in a few minutes. Hey, welcome back. We were able to write some code and get the correct answer, and we have received one gold star. And as discussed, I did not do anything new. I think the only two things that I had to keep in mind was that the delta of movement is always equal to 1, and that you are always going up in elevation where you're moving across. As always, I have written a very well documented code, and I'm going to push it to GitHub. So you can find the link below in the chat or description of the video. And with that, let's move on to part 2. So, and let's make some space here for our part 2. So it says that the reindeer spends a few minutes reviewing your hiking trail map before realizing something and disappearing for a few minutes and finally returning with yet another slightly charred piece of paper. The paper describes a second way to measure our trailhead called its rating. So we have a new concept called ratings. And our trailhead rating is the number of distinct, you see where it's going. The number of distinct hiking trail which begins at that trailhead. So this is nothing but basically number of distinct trails from that trailhead, which is the initial starting position of 0. And we are given an example here. I'm sure this is going to be an example very similar to the first one. So let's increase the font and let's see what we have to do here. So here it says that the above map has a single trailhead that we are starting from here. And then it has a rating of 3 because there are exactly 3 distinct hiking trail. Okay, so if we had to build them, we can maybe use different colors. So for the first trail, we will use red to show again. So it starts from 0, 1, let's go left, 2, 3, 4, 5, 6, 7, 8, 9. So that's the first one. Looking at the second one, in case of turning left from here, if we go straight, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the second part. And looking at the third one, if you go down from here, so 1, 2, 3, and then you turn left, 4, 5, 6, and then 7, 8, 9. So if you see, there are a total of 3 distinct paths that start here and then they end here. And in this case, you could not have taken a left from here because you cannot go down from 6 to 5. So you can only keep going up. So this is how we get this. And similarly, they have another map which has trailhead with rating of 13. So there are 13 different paths going from this, and they don't have to end up at the same position as well. So if I open this and quickly let's do a walkthrough over this as well. It will take some time, but it's always good to get the absolute clarity when looking at these examples. And I'm not going to get like 13 different pens, but let's try that. So starting from 0, we cannot just go here, but we can calculate. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 1. And then from this, you can go up 7, 8, 9. That's 2. 8, 9, that's 3. We can't do anywhere. We can go here. So we'll go 3, 4, 5, 6, 7, 8, 9, 4. So 5, 6, 7, 8, 9, 5, 4, 5, 6, 7, 8, 9, 6, 6, 7, 8, 9, 7, 5, 6, 7, 8, then 7, 8, 9, 9, then 6, 7, 8, 9, 10. What else am I missing? So, oh, there are multiple variations now. So here I'll probably have to use another color. So then there is a variation where you will just directly go down and come here, 11. Similarly here, there is another one where you'll directly come down and do this 12. And then there is the last one, which is interesting, where you will come like this and come like this and go like this, which is our 13th variation. And yeah, this is interesting, right? So now it seems like we are exploring all the paths leading to multiple. So in this example, it's not like we were only looking at one. So we were looking at this, and this end position for the hiking trail. And similarly, we are given an example, and then our output was the rating of, because we were starting from the single point. So this can still be single, but your end can be like multiple ends can be there. So this is another interesting edge case that we have to keep in mind. And we are given in another larger example where there is a trailhead, single trailhead with rating 2 to 7, because there are 121 distinct hiking trails that lead to the 9 on the right edge, this one, and 106 that lead to the 9 on the bottom edge. It's crazy how it's growing. It's almost as if it's exponential. And that's because if you see, this is like completely in an increasing order from top left to bottom right, which means that you can form multiple zigzag paths that will lead you to your final destination. And then they have given another larger example from before. And based on this, considering all the trailheads in reading order, they have different ratings. So the ratings that are given here are 20, 24, 10, 4, 1, 4, 5, 8, and 5. And what we are doing is we are doing sum of these ratings that are there. And that comes to be 81 in the part 2. So you're not sure how, but the reindeer seems to have crafted some tiny flags out of the toothpicks and bits of paper and is now using them to mark trailheads on your topographic map. That's an irrelevant detail, but I'll try to put this in DALI for the thumbnail and see how that turns out. So what is the sum of the ratings of all trailheads? So again, our input example remains the same, but in part 1, we were calculating all the different trails that existed. But here we are trying to calculate the rating. And now is a good time to pause and think that now that we have explained the problem, how would you change your approach and build on top of your solution that you did in part 1? Will you do that, or will you do a completely new novel approach of doing that? Because clearly I can see some of the common things. The whole traversal logic is still the same, where you can go in 4 directions and you always have to keep going up. The only thing that has changed is that, remember, like initially we were ignoring when we would reach the same trail end from a different path. Here, instead of ignoring that, we just have to keep account of it. But think about the problem. And what I'll do is I will go ahead and write some code for this. And once I come back, we will do like a quick retro discussing about how we did and what we could have done better. And I think this is a good time for you to also open up that IDE and write some code. So I will see you in a moment. And hey, we are back. And as you can see, we have received another gold star for part 2 of day 10. And yeah, I just followed the same discussion, same approach. I think the key difference, if you have to take away between part 1 and part 2, is that in part 1, you were calculating all the unique endpoints. So the endpoint here in this example is the highest peak, which we are classifying with number 9. And the key difference, like most of the code remains the same, but the key difference is that instead of now looking at unique endpoints, all you care about is unique paths to these endpoints, right? Initially we were ignoring, and here we are just keeping a count of that when we do. And yeah, with that, in case you're still feeling a little confused by this problem, what I have done is I have like taken extra time to write some really good comments and explanation in the code. So what you can do is you can, after closing this video, you can go to the GitHub repository linked below and you can look at the code and walk through it to understand where the part 2 starts and how we are doing it. And I have also written test cases for all the tests that were given to us in the question. So one of the simplest way of understanding the flow of program is to set up like debug points in your IDE and then run the code and then follow the test case and see how the pointer and the flow of the code is moving. And that should help you a lot. And if you still have any questions or any difficulties, feel free to add a comment below or reach at me on my Twitter/X profile. And I would be happy to clarify anything for you. And with that, we are at the end of day 10. and our sky art keeps getting bigger. I still cannot make out what it is. If you can, please let me know. And yeah, if you like these videos, do comment, let me know, and share with your other engineer friends. And subscribe to the channel so that you don't miss the next video. With that, I will see you for day 11, and you have a very nice day. Bye bye.